Okay, so today we're going to start our study of geometry. Notice we're starting in section 1-2, not the first section of the book. Okay, so as we kind of mentioned a little bit earlier that geometry is broken up into two parts. Geometry, so it's like measurement of Earth. Okay, literally that's what it means. And one person that was really important in developing geometry was a man by the name of Euclid. Okay? Euclid came up with basically 5 what we call postulates. Okay? We're going to learn later on what a postulate is, but does anybody know what a postulate is? No? Okay, a postulate is kind of like a theorem, except a theorem is something you have to prove. Okay? If I give you a theorem in this class, we have to prove it. Every one of them. Okay? So if I tell you that there are 180 degrees when you add up all the angles in a triangle, that's a theorem. That's the triangle sum theorem. We can't use the fact that there's 180 degrees in a triangle until we prove it. A postulate is a little different. A postulate is something that either the book or I or you research and it says it's true and you don't have to prove it. It's almost common sense. Okay, that's a postulate. Something that's true, and you don't have to prove why. It's just accepted as true. You can't prove everything. Okay? You've got to have a starting point. If you tried to prove every single thing, you'd go in a circle. Okay, so there's 5 what we call postulates in Euclidean geometry. Okay, and I just want you to read them. Okay, we're not going to write them all down, I just want you to read them. These are translated a little bit from his original wording that he wrote, but it's the same basic idea. Okay, so first postulate says you can draw a straight line from any point to another point. That's it. So if you've got 2 points, you can connect them with a straight line. That's our first postulate. Okay, a straight line can be extended as long as you want. You can make a line any length that you want. Notice it says finite. Finite does not mean infinite. Finite means it has a fixed length. Okay, so we can take a line and make it any fixed length we want. Millions and billions of feet if we want, but we can make it any length we want. Okay, the next one is about a circle. There's only 2 things you need to describe a circle. If I asked you to draw a circle on, say, an XY axis, I need to tell you 2 things if I want you to draw it a certain way. One, I need to tell you where its center is. And then I need to tell you its radius. That's it. Okay, so a circle can be described with just those 2 facts. Where do you want the center? How big do you want the radius? Okay, the 4th one, all right angles are congruent. Okay, we're going to learn later on a right angle is basically an angle that's 90 degrees. Okay, and the last postulate says if a straight line intersects 2 other straight lines, okay, it's using some words we might not know yet, and makes the 2 interior angles on one side of it together less than 2 right angles, then the other straight lines will meet at a point if extended far enough on the side of which the angles are less than the 2 right angles. Okay, that one's a little bit more confusing. All right, it has to do with lines being parallel. All right, so I don't want to get into it too much because that one's confusing. I think the first 4 you can understand pretty easily. Okay, and they tell you right here below, postulate 5 is called the parallel postulate. All right, this one is really specific to what we're studying, which is called Euclidean geometry. Okay? In Euclidean geometry, when you draw parallel lines, what does that mean? Parallel lines what? Yeah?
They never intersect.
Right. In Euclidean geometry, they never intersect. But there are other kinds of geometries, besides the ones that we're studying, that kind of change the rules a little bit. Okay? There are types of geometry when you draw parallel lines and we say that they do intersect. They intersect very far away at infinity. Right? That's not the way that we're going to look at it, though. Okay, that's a little bit more advanced and not what we're used to. So we're studying what's called Euclidean geometry, named after the person I said earlier, Euclid. All right? So he did so much to develop geometry, they named the whole subject you're studying after him, Euclidean, from Euclid. Okay? And there are two important tools that we use in geometry, a ruler and a compass, or more specifically, like a straight edge. All right? So as long as we have a straight piece of metal, it doesn't matter, just something straight, doesn't have to have marks on it to measure length. That's a straight edge. Okay? Once you put marks on it to measure length, it becomes a ruler. Okay? So a straight edge and a compass. Okay, that's a compass. Has everybody seen a compass before? Okay, you can kind of bring it out and you can use it to draw a circle, things like that. So using a straight edge and a compass, we can do lots of different things in geometry. And that's part of what we're going to learn as we go. Okay, I'm going to show you how you can use just those two tools to take something like that and cut it exactly in half. And all you need is this compass and a straight edge, okay? Without any measuring. Okay? What's wrong with measuring something to cut it in half? Think about that. What could go wrong if you try to measure something to cut it in half? About Ian?
You get the incorrect measurement.
Yeah, if you measure it wrong, or you can't measure it precise enough. Let's say I want this exactly in half. I want this exactly in half to the nearest 10,000th of an inch. Well, it's going to be pretty tough to measure this line to the nearest 10,000th of an inch. Okay, we don't have a tool that's good enough to do that in this room. All right? But I don't need a tool to do that. Give me a compass, give me a straight edge, I can show you how to cut that in half. Okay? Similarly, we can extend that a little bit to an angle. Let's say I want to cut this angle exactly in half. I can do that with the same two tools I just showed you. Okay, so part of what I test you on, part of what you're going to learn is how to use these two tools a little bit. All right? We'll maybe learn how to do 6 or 7 things with them. Okay, so that's kind of a basic introduction to what the foundation is for geometry, those 5 postulates, and kind of our tools of the trade. Okay, in geometry, it's a compass and a straight edge. Okay, so now we'll get into some of the definitions. And today there's a lot of definitions because it's the first day and there's a lot of terms. Okay, we're going to use these terms pretty much throughout the year. Okay, so first term I want to define is what is a definition. Okay, so a definition basically uses words you know to describe a term that you don't know. Okay, that's a definition. In the back of your book, there's a index, or I think there's also a glossary of all the different terms that we're going to learn. Okay, and if you look at it, there's also a section in the back that has every theorem we're going to be learning all year. Okay, so if you flip, let me just take a quick look. Okay, a lot of the definitions have pictures. That's very helpful to kind of understand what they're talking about. There's some tables of symbols, and then theorems. Okay, on my book it's page 826, right around there, 827. All the postulates and theorems we're going to be learning all year. All right. So that's going to be a helpful page to go back and look at, around 826. Sometimes we have some terms that are kind of strange to define, okay, tough to define, and we call them undefined terms. Okay, undefined terms. Okay, I'm going to do my best to try to give you a description of the term. I'm going to show you 3 of them right here, but they're terms that are challenging to give a definition that is worded appropriately. Okay, the first term we're gonna look at is called a point. Okay, a point. Anybody know how to explain what a point is in geometry? A point. I'm going to try to explain it, but it's tough. It's not easy. Yep.
Any given spot and a plane.
All right, so it's a given spot. So you're talking about a location. That's pretty good. It is. It's a location. How about in terms of physically? What does a point look like? Like if we're going to try to draw it on paper, what do we use to represent a point? Yeah. How about here? Yeah, we put a dot. Okay, we put a dot. That's the best that we can do. So a point is used to represent a location, and it has no dimension to it. What does that mean? If something has no dimension, yeah, Connor?
It has no measurements.
No measurements, right. It has no length, it has no width, it has no height. So what does that really mean? If something has no length, no width, and no height? Physically, what does that mean? Yeah, it doesn't really exist. See, this is where we get into kind of a weird, definition here. A point has no length, it has no width, it has no height. So how can it exist? Its length, width, and height are zero. So a point is almost more of a concept. It's the idea that you put a dot where you want to locate something. All right? But again, this thing right here, this is a dot. This is not really a point. I could measure that. That dot has length and width to it. Okay? So that's our first term, a point. Okay, the next one is a line. Okay, a line. Any thoughts about a line? How could you explain to somebody what a line is? About Nick? What do you think?
An extended one dimension.
Okay, what does that mean?
It means it starts somewhere and goes
It starts somewhere and it
ends somewhere.
ends somewhere. Okay, does everyone agree with that? A line starts and ends somewhere. Yep?
No.
No.
Extensive, yeah, in
Okay.
either direction.
Okay, so yeah, a line is a little different than what we call a line segment. Lines do not have a start point, and they don't have an end point. They just go on forever in each direction. Okay, what he was right about, though, it is one-dimensional. Okay? Lines have length. They don't have width. They don't have height. Thickness. Okay? And it's kind of difficult to say how to represent a line without using the word line. In fact, I think your book uses the word in the definition. That's generally not a good idea. So I tried to rewrite it the best I could, saying a line extends in one dimension and is represented by a straight mark, okay, with an arrow on each end. Okay, and what the arrowhead on each end indicates is that it goes on forever. It's a little hard to see, but there are arrowheads on the end of each end of that line. Okay, so no starting point, no stopping point. That's a line. Okay, one more definition we're going to look at is a plane. Not the kind of plane like airplane kind of plane, but a plane in geometry. Anybody know what a plane in geometry is? Can anyone think of a term? There's a term that I think you know that has the word plane in it. It's actually the second word in this phrase that you've done a lot with dealing with like an XY axis before.
Coordinate plane.
Coordinate plane. Okay, that's probably one of the more popular places you've seen it. How big is the coordinate plane? Well, Olivia, how big is a coordinate plane?
It doesn't matter, does it?
What do you mean it doesn't matter?
Well, doesn't it go on a graph?
Yep, we can use graph paper to draw one, sure.
Well, you can make it go however you want that way.
Sure, we can make it as big as we want. Okay, so a coordinate plane extends forever. She kind of pointed left and right. That's true. What else? Coordinate plane also extends forever in which other direction, Katrina? Up and down. So a plane is kind of like a line, except now we're in not one dimension, but we're in two dimensions. So think of like a piece of paper that just went on forever in each direction. That's a plane. It has length, it has width, but it has, well, a piece of paper technically has a very small thickness, but pretend it didn't have thickness. And generally, that's how we draw a plane. Kind of think like you're looking at it from, a perspective, from an angle. You're not looking at it straight on, kind of like that. So it kind of looks like a parallelogram or a rhombus kind of idea. Okay, so that's a plane. Any questions on those three terms? Point, line, plane. Okay. Okay, the next thing is collinear points. Okay, the word co means with. So that might give you a hint about collinear points. Co means with. How about linear? If you look at the word linear, what word do you kind of see hidden in there? Linear, yeah, Nathan? Line. Okay, so collinear basically means with the same line, or points that are on the same line. So if I say to you, 2 points are collinear, what I'm saying is there's 2 points and they're both on the exact same line. Okay, so here's a question to think about a little bit. If I give you 2 points, only 2 points, are they always collinear? If I give you just 2 points, what do you think?
Yes, you can always draw a line between the two.
Absolutely. That was one of the first postulates in Euclid's postulates. Okay? You can always draw a straight line between any 2 points. So if I give you 2 points, they're always collinear. When I add a third point in, not necessarily. Picture 3 points arranged like the vertices of a triangle. They're not collinear, all 3 of them. But 2 at a time, always collinear. Okay, and likewise, coplanar means 2 points on the same plane. All right, so think of the table in the front of the room here as a plane. Right? If I put objects on this table, like I have now, all the objects are in the same plane. They're all at the same height, and they're all in the same plane. Okay? Now imagine I had another table on top of that, and I stacked something up here. Well, now the objects up here are not in the same plane as the objects down here. They're in different planes because they're at different heights. Okay, we're all in the same plane right now. Okay? We're all standing or sitting on the same floor. So our feet are all in the same plane. Okay? If I was standing up on the table, I would be in a different plane than the rest of you. Okay? So that's the idea of coplanar. Okay, so here's an example. And we're going to look at this diagram and answer some questions. Okay, so what I've drawn is a plane. I've drawn a line in the plane. Then I have another line that's coming down and going through the plane. Whenever you see something dotted in geometry, what does that mean? You know what that means? It's the best we can do to try to show that something is what? Yeah, Connor?
It's a hidden line.
Hidden, yeah, it's behind. Okay, you can't see that. It's going down behind it. So what you want to imagine here is I took a piece of paper, drew a line on it, and then took like a pencil or something and put it right through it. Okay? And this is the bottom of the pencil coming out where you can see it, and this is going down behind it. Okay, first thing I want to do is name 3 points that are collinear. Okay, there might be more than one answer. There might only be one answer. We'll see. Okay, but can anybody name 3 points that are collinear? Here?
D, E, and F.
Yeah, D, E, and F. D, E, F. Are there any other 3 points that are on the same line? Anybody think they see anything else? I see maybe 2 points that are collinear, like E and H, but I don't think there's 3. Okay, that's the only answer for part A. Okay, next one I want is 4 points that are coplanar. 4 points that are coplanar. Okay, how about Brian?
That would be
D.
E, G, E, F.
So E, okay, that's 1.
Yeah,
And then F, you said?
yeah.
Okay, that's 2. Need 2 more.
D, G.
Yep, and D and G. Perfect. The order you list them in isn't overly important. Alphabetical order might be nice, but that's fine. And those are the only 4 points that are coplanar. Now, if I asked for 3 points that are coplanar, you could say any 3. You could say EFD, FDG, DGE. Okay, there'd be lots of answers if I asked for only 3. Okay, but in this case, there are only 4. Okay. Now I want to know 3 points that are not collinear. And this one, I think we have some multiple answers. Okay, I want to know 3 points that are not collinear. Yep, Dakota?
D, H.
Yeah, D, E, H. Sure, H is up in the air. H is off the plane. Okay, so that's definitely not collinear in this case. D, E, H. Okay, anybody see another one? 3 points, not collinear. Yep, Connor?
D, G, H.
D, G, H. Yep, not collinear. Okay, anybody see a third one? I think we can stop with this one, but we got one more. Kira?
H, E, G.
H and E, those are collinear, but then you throw in G and now they're not. Okay, would GEH count as something different? Would that be different than HEG? What do you think, James? No. Listing points in different orders doesn't count as a different way to solve this. Okay, so there's some good examples of 3 points that are not collinear. Okay, so we're going to look at a few more basic terms. Okay, when we talk about lines, points, and planes, you want to have symbols to represent them. Okay, there's a few different ways that you can symbolize a line. Okay, the first one is more of a drawing of a line. That's not really a symbol. That is a line. You've drawn a straight mark and you put an arrowhead on each end. And to talk about lines, we generally need to put 2 points on it to identify it. So if we had this symbol right here, the way you could describe that symbol is either an A and a B, and then you draw a line above it. Or you could say B, A, and put a line above it. Most of the time, I go with alphabetical. Okay, so those are 2 symbols for a line. How about a line segment? How about rows? What's the difference between a line and then a line segment? Well, what if I said to you something like, we're going to review just a segment of what we did in class yesterday. We're going to review a segment of what we did. What does that mean?
Like not all of it.
Not all of it, right? Part of it. Okay? So that's basically what a line segment is. A segment is part of a line. A segment has a beginning and an end. So it's just a small portion of a line that connects 2 points, and it looks something like that. Notice when we draw it, we don't put an arrowhead on each end. There's a point on one end and a point on the other, and they're labeled AB. And A and B are called your endpoints. They're the endpoints of the segment. Any guess how we symbolize a segment? It's similar to how we did a line, but it's just a little different. Thought how you'd write it down. We don't generally want to write down line segment AB. That's going to be a lot of writing. I'm use an abbreviation for it. Yeah, Ian?
Draw a small little line segment and put AB under it.
Yeah, it's pretty much like that. Okay, you draw AB. They generally don't put the dots on the end points, but they just draw a straight bar over AB. Or you can do BA. Same thing. Okay, so we talked about the symbol for a line, for a segment, and there's one more concept that's kind of tied in with these two. Anybody know the other type of thing that's straight? And it's kind of a combination of a line and a segment together. Jacob?
Array.
Array, yeah. We also have array. Okay, array is like a line, but instead of going in 2 directions forever, it only goes in 1. And there's a picture of array. Now, all this time I've been saying the order doesn't matter. Okay, if you write the symbol for a segment, AB, BA, doesn't matter. You write the symbol for a line. Okay, and it could be other letters than A and B. It could be X and Y, But the order of the letters doesn't matter. How about with array? What do you think? Does order make a difference when you're talking about array? About Tanner? You don't think it matters? Okay, so we have a yes for doesn't matter. Anybody else have a thought? And maybe why they think what they're thinking? Yeah?
It doesn't matter because it's a definitive start point.
Okay, so with array, there's a difference between AB pointing to the right or if it was pointing to the left. Okay? The order that you say the letter is in with array tells you first letter is the start, the second letter is the direction it's going in. Okay? So this particular ray would be symbolized by starting at A, going to B, and continuing on. And you put an arrow. What's a little funny is the symbol always uses an arrow pointing to the right. If we wanted to talk about the ray that would be pointing left, we wouldn't switch the symbol when we're writing it. We would switch the letters under the symbol. So if you want to talk about this ray, the symbol for this would be that, right there. All right. Starting at B, heading towards A, and continuing through it. Okay. Any question on the notation for lines, segments, and rays? Okay, once we start to get through the first chapter or so and get through all this notation stuff, then we're going to start really doing more kind of applications. All right, but especially this section, there's a lot of notation. Okay, so A, as I already said to you, that's called the starting point or the initial point of the ray. Okay, so here we've got something kind of a special situation. This is not a line. Okay? How do you know? I tried to do the best I could to show you that this is not a line. How do you know that? Yeah.
So there's two different colors coming out of the same point. They're two different rays.
Yeah, it's two separate objects here. They each have the same initial point. Okay, but it's two rays going in opposite directions. And that's pretty much the name of what this is. They're called opposite rays. Okay, so the blue ray, ray CA, and the red ray, ray CB, are opposite rays. They have the same initial point, but they extend in opposite directions. Okay, we're kind of far from this right now, but does anybody know the angle? Like if you were to draw right there, how many degrees that is between the two? If you started to fold them together, it would get smaller. But when they're open as far apart as they can go, how many degrees is that? Yeah, Katrina? Yeah, they're 180 degrees. That's the angle between them. And that'll tie in with things we do later on. Okay, so opposite rays start at the same point, extend in opposite directions. So with all these definitions, what I might do on a test is give you a word and ask you to define it, or I might give you a picture and ask you to describe it that way, using certain terms. Okay, any questions on opposite rays? So segments and rays can be collinear. Just like I said, points can be collinear if they're on the same line. Well, segments and rays can be collinear if they're on the same line. Okay? If you were to draw a line through all of the points A, B, and C, these two rays would be collinear. They would be two rays both on the same line. Likewise, segments, rays, and lines can be coplanar if you draw them in the same plane. So if I were to bring up my graphing calculator, and from Algebra 1, draw a line y equals 2x plus 3, and y equals negative x plus 2. And let me turn those other dots off. I've just drawn two lines that are coplanar. coplanar. They're both drawn in exactly the same plane. Now, if I started to do 3D graphing, and I had one line here and another line coming out of the board, those wouldn't be coplanar anymore. Okay, coplanar, anything drawn in 2 dimensions is automatically coplanar. 3D can mess that up. Okay, so here's one where I want you to draw something. All right? These questions, that some people have a little bit harder time with it because they have to actually draw, sketch something. So I want you to draw 3 non-collinear points, J, K, and L. And then I want you to draw this, the second one, and the third one. Okay. How do we pronounce the first one? What am I asking you to draw there? Yep. Line JK. How about the second one? How do you pronounce that? About Justin?
Segment KL.
Very good. That's segment KL. And how about the third one? Yep. Owen.
Ray LJ.
Ray LJ. Those are the 3 things I want you to try to draw. Okay, so take a second on your own and see if you can do that. Okay, then we'll come back and we'll take a look. Okay, so let's take a look at drawing those 3 points. Let's make that a little bigger. Right, anybody want to come up and try to draw 3 non-collinear points, J, K, and L? You want to try it? No? All right, I'll do it, but eventually I'm going to probably ask for volunteers to come up and try to sketch some of this stuff. So J, K, and L, pretty much put them anywhere you want. Just don't put them in a straight line. Put them as like the vertices of a triangle. So you can put J, K, and then don't put L in a straight line. Just put it somewhere over there. Okay, there's 3 points that are non-collinear. And you could have done it differently, but that's just how I did it. Right, and now we just draw the 3 things in. Okay, line JK. Okay, to draw a line, make sure you've got that arrowhead going on each direction. Okay, and put that over there. Okay, so there's line JK. Okay, segment KL. Okay, on that one, you don't want to put your arrowheads on it. Make sure that it starts and stops at K. Starts at K, stops at L. And Ray LJ. Okay, this one's important that you have it start at L and go towards J. Just like that. And there's an arrowhead on it to indicate it keeps going. Okay, any questions on that? Okay, this is jumping ahead a little bit, but is that shape a triangle? What do you think? More generally, I could ask, is that shape a polygon? But the thing that it's kind of closest to is a triangle. So is that shape a triangle?
I don't think it is because the lines continue on.
Right, it's not. This is not a triangle because it's got 2 sides that keep going and they intersect at that point. To be a triangle, they'd have to have 3 line segments. So this shape is not a triangle. Right. Again, that's jumping ahead a little bit. All right, so here's another drawing one. I'm going to give you guys a chance to do it, but then I'd like someone to try to come up. It says to draw 2 lines. Label points on the lines. If you don't label points, you can't really describe things. So you got to put some points. You could use A, B, C, X, Y, Z, any letters you want. And then I just want you to name 2 pairs of opposite rays. Okay, so try to sketch that. 2 lines. And I want you to name 2 pairs of opposite rays. All right, so again, we're looking for 2 lines, We're going to have to label some points, and then I want to label some pairs of opposite rays. Okay, so first thing is, let's just try to get the sketch. Okay, don't worry about the opposite rays yet. All right, so Connor, we're going to come up and try to draw that. So he's going to draw 2 lines. So there's 1, there's 2. And now if we want to name some opposite rays, we've got to label some points. Okay, where they intersect, that's a good one to label. You're going to use that point, I think, every time in this problem. So we've got the intersection is F. We've got the upper right ray there is C. Upper left point is A. And the lower left looks like we got D and B. Okay, so he's got ray FA. And he's writing the ray opposite to it, which is, let's see, FB. Perfect. Okay, so that's one pair. And he's got FC. That's another ray. Now we just need the ray that goes opposite FC. FT. Very good. Okay, any questions on that? Okay, the only thing I would do is, I don't know if we can, but yeah, either just take these two and move them over a little bit just so I know that you have 2 different pairs, or draw a line between them, but that's perfect. So ray FA, FB, FC, and FD. And he labeled 5 points, which is exactly how many you need to label in this problem. Very good. Okay, any questions on that? Okay, we're going to come back to this kind of diagram quite a bit. Okay, what we've created here is a picture of what are vertical angles. Okay, has anybody ever heard of vertical angles before? A couple people? We'll talk more about what those are, but basically, if you were to measure this angle and that angle, they would be exactly the same. And if you were to measure this angle and that angle, they would be exactly the same. And the marks that I just drew show that. Okay, I drew the kind of this curved arc and this curved arc. Any angles in this picture that just have one curved arc are the same measure. All the angles that have the 2 curved marks are also the same measure. Okay, that's, again, jumping ahead a little bit, but I'm just trying to show you the kinds of things we're going to eventually be doing. Okay, so when we drew our last picture, we had 2 lines that intersected. Okay? We can have many kinds of things that intersect. Okay? They don't have to be lines. Okay, when you draw 2 lines, they could be parallel, then they wouldn't intersect. But assuming they're not parallel, how many times can lines cross each other? Owen? Just one time. If you draw 2 lines, they can only cross each other one time. Is that always true? If you draw, in general, 2 geometric figures, do they always cross each other one time? What do you think? How about Alyssa? If you draw any 2 geometric figures, not just lines, will they always just cross each other one time? No. Could you give me an example of something you could draw that would cross more than once? Think of maybe a line with another shape. Okay, if you drew a triangle with a line, that would cross more than once. If you drew a circle and put a line, that could cross more than once, depends on where you put the line. If you draw, for example, this shape, anyone remember from Algebra 1 what y1 is? X squared, what shape is that? It's not a straight line, it has a curve to it. Yeah? Not an ellipse, it's a parabola. Okay, it's a parabola. So if I draw something like this, it's going to cross the parabola twice. Right? And sometimes we want to know where it crosses. That's algebra. Okay? Or we can also use a graphing calculator to find where it crosses. Okay, but the point is where two things cross, that's where they have a point or many points, if there's many intersections, in common. So the intersection of the figures is the actual shape that you get. It's all the points that the two things have in common. Okay, so you're going to draw some sketches, but the first thing I want to do is just think about what it's going to look like, what the intersection is going to look like. Okay, so the first one they want us to sketch is a line, and the line is going to intersect a plane in one point, meaning we're not taking a plane and drawing a line across the top of it. We're drawing it through it. Let's show you, I think we had a sketch of that earlier. And basically what we're going to do is draw a plane. And we're going to draw a line coming down. It's going to hit the plane right there, and then it's going to continue passing through the bottom and get dotted, and then we'll see it coming out the bottom. What does the intersection look like there between the line and the plane? If you had to describe to me the intersection, what is it? Yeah.
It's like two opposite, right?
Well, remember, the intersection is just the points they have in common. So all of the points that are on the solid part here are up off of the plane. So it's not intersecting there. The intersection between the line and the plane is just a what? Yeah.
Point.
It's just a point. That's exactly it. Okay? The intersection here is just a point. That's not always true. But the way we drew this one, it is. Okay, so the intersection is a point. Right, so I'm going to draw now two planes that intersect. Okay, and there's different ways you can do it. I'm going to draw it a certain way, and I want you to try to describe the intersection to me. Okay, so let's see if I can draw this the best I can. Okay, let's start with one plane. Make that part dotted, because that's going to be, you're not going to see that part in a second. And let's see. I'm going to have another plane kind of come out in front. It's going to go over. Actually, not quite that far. So I go right to there. Have it go back, and now it's going to go behind it. Over to about right there. And so it's kind of going behind it. Okay. I guess that part would actually be more solid. It would just be this part that's dotted. So sketching things like this can be kind of tough. Okay, but the plane is cutting through right about here. Okay? I can try to show it right along there. What would that intersection look like? Two planes intersecting. Okay, another way to visualize it is try to take these two pieces of paper and just pass them right through each other. It's not going to be a point. And keep in mind, these planes really go on forever. Yeah?
Line.
Yeah, this would be a line. Okay, so the intersection is a line. And as I said before, it's a line kind of right there. That's where the piece of paper is passing right through. If that's hard to visualize, another way to think about it is you can just look in the room and imagine the ceiling as a plane. Imagine the front wall as a plane. Where do the ceiling and the front wall meet? They meet in a line all the way across the top of the room. Okay? And that's what I try to do if I have to visualize something really complicated. I try to look around me and see if there's something that kind of looks like what I'm trying to visualize. If I wanted to visualize three planes intersecting, I could still use the room. One way to visualize it is with the front wall, the ceiling, and the wall where the windows are. All three planes meet in the very corner of the room, which is a single point. Right? That's not the only way to draw three planes. But if all of them are perpendicular to each other, like in a room, that's what it would look like. Okay? I'm not going to ask you to draw anything much more complicated than that, though. All right. Any questions on that? Okay. So that's the basics of section 1.2. Okay, notice we didn't talk very much about angles today. We're going to talk about angles and acute angles, things like that later on. Okay, so for tonight on page 13, I'll have you try 1 to 25 odd, 31, 33, 39, 46, and then 55 to 59 odd. If you have to draw any shapes, try to use your ID or use a ruler, whatever you have for a straight edge, to make your pictures look pretty good.